If you ever take the time to look at the forests of southern Quebec, you'll see a living landscape. Hills covered with deciduous trees, maple groves, and a beautiful patchwork of softwoods. As climate change is disrupting our ecosystems, we know for a fact that our forests are set to evolve. And as they do, the distribution of tree species will shift in an uneven and often unpredictable manner, usually receding north. This is where Peter Osborne's work come in. Having recently completed his PhD here at McGill, he essentially defines the forest not as an inventory, but rather as a distribution of living beings, each with valuable traits. At the same time, building elements are assigned their own specific traits. The forest building framework is one that reads both the systems through their functional traits and synchronizes them in order to design for resilience in an unpredictable environment. Osborne's work gives us the approach and data for a resilient forest building framework, but not for an implementation. The aim of my thesis proposal is to offer an architectural application for this system. Many hardwoods from southern Quebec remain underused in contemporary building systems, which surprises me considering hardwood such as the sugar maple is deeply rooted in Quebec culture. It was, for example, used for sugar shacks, firewood, and even ancestral furniture. The environmental adequacy and custom-made nature of those applications that we inherited from previous generations were often overlooked in today's industry. So the task is to put this trade-based approach into practice in order to show how diversified use can actually support forest resilience while meeting performance needs. I think a great starting point for the design part can be to ask myself, if I had to build a house entirely out of maplewood, where would I start? Step 1 is selection. I will choose a set of underused hardwoods through a trait filter that builders and I can actually use. Step 2 is design. I will sketch families of details for building envelopes. Step 3 is prototyping. I will build one-to-one models to test behavior and adaptability. Step 4 is cataloging. I will gather the drawings and prototypes into a collection that links tree traits to real construction uses. If forests are changing, our buildings should shift with them. Let's care for our forests, design with resilience, and actually build with the wood that's most available.